Tulane University School of Architecture here in New Orleans, we're very local in the sense that our studio aims to explore the potential precast system to address the critical issues of our time and place. We occupy Mississippi Delta, the complex ecological system formed by the soil deposits interacting with the river and the Gulf. In this soft fluid ground, finding stability in is a constant challenge. And we think that the concrete offers the opportunity for a symbiotic relationship between this landscape and the built environment. The studio is an advanced research-based studio for graduate students. We had 9 graduate students this semester, mostly in their second year and their third year. The studio hypothesis is that through advanced design and fabrication techniques, the surface geometry of the precast system can be performatively and aesthetically aligned to the flow characteristics of water, mitigating flood and encouraging productive occupation of the ground plane. So at the component scale, the studio obviously pushes the limit of the complex surface geometry and advanced fabrication techniques we can afford, and its performance relative to water. We've also been looking at the context of our city to make an urban scale impact. And the key data here about New Orleans, on average, we get about 1/2 inch of rain over 24 hours every 3 days or so. However, lately, as you know, we have been experiencing a much more frequent intense rainfall, about 1/2 inch of rain over an hour or 2. And this is actually an equivalent to the intensity you experience in a 10-year storm overwhelming your drainage system and leading to significant flooding events. As you see here, this is a typical model of 10-year storm, and the intensity, peak intensity is about 0.6 inch of rain within about an hour time. And what this does is it overwhelms our drainage system. What you see here is the network of New Orleans drainage system. The site we've been looking at, we'll talk to you a little bit about, is over here in the circled in the red dash line there. The site we've been exploring, the Lafitte Greenway, happens to be in the primary drainage route parallel to the open drainage canal. Locations and the capacity of the pumping stations are represented in a circle here. As you know, New Orleans is mostly below the sea level. So in order to extract water out, you need to pump up in order to gravitationally drain. And mostly right now is draining out to the Lake Pontchartrain. The obvious response to the frequent flooding events are to either increase the size of the drainage system to move more water quickly, or decrease the peak demand for the drainage system by increasing the water detention capacity. So the studio takes the latter approach. We, with the help of stormwater management expert here in the city, we looked at the impact of diverting high flow stormwater from the adjacent drainage canal and detaining it on our site by controlled flooding. And this is the Lafitte Greenway. It's sort of like the New Orleans version of Highline, I guess. French Quarter's right over here, CVD, and Lower Garden District. And a lot of the water gets routed out here and drained out into Lake Pontchartrain. The simulation analysis with the SWIM model, stormwater management model operated by the city, confirms that if we could detain a fairly substantial amount of water here, it will reduce the flooding upstream in the upstream. So it actually impacts the upstream, the CVD and Lower Garden District. So what does that mean? Based on our analysis, approximately 450,000 cubic feet of stormwater needs to be diverted and detained to have an impact. And our site is actually exactly around 450,000 square foot. So that means it's a 1-foot excavation across the site. As an example here, with a cut and fill strategy, it translates roughly 3-foot excavation, 1/3 of the site, and 1.5-foot fill 2/3 of the site. Note that the water table is high. We can't go down that far because the water table is about 4'6" below the sidewalk. And in order to do controlled flooding, we need forebay. Forebay is an infrastructure for controlled flooding to release the water slowly and evenly to mitigate soil erosion, improve water quality, and to promote productive use of the site. So we have to have a forebay. It's an infrastructure, and it's responsible for about 25% of the detention capacity. In this case, it's about 112,500 cubic foot. It's connected to the canal at 4'6" below grade, and water, the water in the forebay will rise simultaneously with the water level of the canal. So at the site scale, our intervention focuses on managing the occasional controlled flooding 4 or 5 times a year and the water detention through forebay design, managing the normal stormwater runoff and improved water quality, and to develop the use and the increased value of the Lafitte Greenway for the neighboring community. And we've been exploring the innovative use of precast to do this. How do we do it in the studio? We start the semester with 2 3-week exercise to build up the skills. We do need to build up the skills. First is an eccentric unit exercise, introducing students to the idea of modularity, clean surface modeling, and iterative 3D printing. 3D printing became a big thing because of the COVID. And the second exercise is the water retention vessel exercise. It's a controlled complex surface modeling, surface geometry representation and analysis, G-code translation, and CNC milling of the formwork. And we use hydrocal as a casting materials for speed and testing. Then we're ready to tackle the site. And fortunately, this is our 3rd iteration. So we've been building up the site analysis from previous semesters. So we can use that, students can use that to quickly settle on the site strategy and develop program and surface geometry of the site. This project envisions a cypress nursery as a program, and concentrate on the design of the precast components to control the geometry of the ground plane and water. This project based on the precast sheet pile retaining wall and to create a subtle topography. As you know, New Orleans is very flat, and 5-foot change does wonders. Surface geometry of pile, direct water flow. And this project focuses on the precast forebay system, the spiky things intruding into the site. And the forebay also act as a biofiltering system and accommodate benches to foster occupation along the forebay. We did have much of challenges because we couldn't, out of 9, 2 of the students are fully remote. So our attitude was to see what we can do. Remote in the sense that they were still local, they were isolating because of their health, the existing health issues that they had, so they couldn't come into the studio. So, we've been obviously pushing the digital technology quite a bit. So 3D printing, CNC milling, and we thought maybe we can really test out how the fabrication works in the remote condition. This is kind of an existing condition that how we deal with the fabricators, architects deal with the fabricators these days. So we thought maybe that will be an interesting thing to look at. The reality is, because that we are in a fall schedule, for instance, a CNC lab, also student staffed, and there is some delay in organizing the lab to accommodate the capacity. On top of that, a lot of other studios were clamoring to use something like CNC or 3D printing, and which really diminished our capacity to iteratively do things. even 3D printing is not fast enough. You're waiting, a day and a half to get your 3D printing. The design has to progress much faster. So, I mean, it was remarkably successful for the given conditions. However, I thought long for the days that we can come back to operating normally. Thank you.
So I have a question. I mean, it's not necessarily related to teaching of the course, but I'm kind of curious. You've done some cool stuff with concrete and building the water storage capacity. But I also realize that's a lot of concrete. I'm curious, what advantage does the concrete have over a natural greenway that has some levees built up for water storage?
So we're not lining the strategy is to try to minimize the use of concrete in your, but you have to form the surface geometry in ground. So a lot of the use becomes something like a retaining wall, strategically placed retaining wall, or the where to diffuse the water flow, so it will become an erosion control on the specific locations. And then the rest of the site naturally, and we actually, it's really a landscape project on the other end, because we're also looking at planting material. I didn't talk about that, but so on and so forth for landscaping the site. So there's a lot there, but the idea is that I think one of the things is the precast industry faces from an architectural perspective, something like a precast parking structure probably don't have much future, right? Because all the advance in auto technology. And B, there's a competition with CLT, and the heavy timber type of construction. But where the precast system have advantage is where it faces the water, especially that's really relevant to us where we live. And we're trying to see if we can produce some kind of well-designed product in that regards through precast. Does that make sense? We don't want to use too much, so it's also always sort of a balance between how much concrete we should deploy and so on and so forth.
Were you able to get out to any of your partners this year?
Yes, thank you for asking. And it was all done by digital. So we weren't allowed to travel. So we did this digitally in engineering firm like Forterra Engineering Products, BioClean Products presentation, mostly the more of the PCI related firms that specialize in infrastructure participating. We learned a lot. Also, Dan Eckenrode gave us a really, really nice lecture on retaining walls, modular retaining wall system. And those were really, really helpful. Also, with the PCI support, we were able to engage local engineers to help us with some of the more civil engineering type analysis. So, what we do is not just looks, we have a credible quantitative reasoning why we're doing what we're doing. And that was sort of the key lessons for us.
And Taro, did you find any platforms like online, like Miro or something like that, that allowed you to integrate the remote students into the studio? And were there any practices that you used to have the students work together? Because I'm going into my studio right now. We're all in person, but given last semester, there were people becoming symptomatic and they would have to go remote and stuff like that. I'm just wondering if you found anything that really worked robustly.
So, well, we used the concept board as a pinup board and Zoom for reviews. And actually the individual review part works pretty smoothly. It's more of an issue when we have a larger pinup. I mean, again, it's a small group. We only had 9 students, so small group, it works better. If you have a larger group, it's just the conversation's not as spontaneous, and you start to lose the important things that normally falls on the margin, just kind of falls away, and it's very frustrating from a professor's perspective.
I sat in on a couple that used Miro, and that seemed to work really well.
That's what we used in the fire drill last spring. So I was just wondering if anyone had found anything else that they added into Miro or anything like that. To review the 3D models, were you just using screen share and annotation for that, or is there some collaborative 3D software that you know?
Good question. And yeah, it was just screen, as you said, but I think there's a product we're looking at now, the AR augmented reality softwares that potentially could push those boundaries, but we'll see about that.
The operative word being potentially.